Okay, so today's training is actually on natural language processing. And what we want to do for these 2 days is the foundation of natural language processing, which we call NLP. Um, Natural language processing is actually a part of, or is an aspect of artificial intelligence. And most innovations you see today, most solutions of AI, they thrive on the knowledge and expertise of natural language processing. At least one example is the chatbot you see when you visit a website, or you're trying to you visit a website, you want to make a purchase, whether maybe you want to book a flight, or you want to buy a product. You see a chatbot on that website saying, trying to attend to you. The back of it tries on natural language processing. It was built using natural language processing, because natural language processing actually is a field that deals with analyzing and processing of text data. Everything you're going to be dealing with in this is text data. Why is it so important these days? And that's one thing I would tell you, is because with the advancement in social media, text have now become more popular. That because it's classified, text is classified under unstructured data. Gone are those days where data will always come in form of, as in a structural form, like in rows and tables. Most of the data out there now are unstructured. One example of unstructured data is text data, where natural language processing comes in. You can have images too, and like that. But the common one you will see now in almost every business is text data, and that is where natural language processing comes. So in the next few minutes, I'm going to walk you through applications of natural language processing, application of NLP, so that you can have an idea of where, if you decide to major in this field, which is an aspect of artificial intelligence, you will have an understanding of where you can make impact for a particular business or a particular company you are working for, or product you are developing. One common one is what we call the sentiment analysis, or analyzing sentiment. So, but the question is, what is a sentiment? I put here that the sentiment, when you talk about sentiment, it reflects a positive or a negative or neutral opinion or thought of a particular person concerning a product they consume, or concerning a particular brand. For instance, if a company wants to look at how the popularity of their brand, or how satisfied their customers are, or the trend of a particular fashion, or a particular fashion design they are producing, this is where analyzing the sentiment, because customers, after buying product, you will see, even in Amazon or Jumia, they can tell you to rate the product. What they are doing with those ratings is to perform sentiment analysis to be sure how people are satisfied, their customers are satisfied with their product. So when they get out the ratings, or in terms of words, or the rating is what they will classify into sentiment. It could be positive, it could be negative, or it could be neutral, something like that. Another popular one is what we call the named entity recognition, which are and when we talk about named entity recognition, I abbreviate as NER, is a type of labeling text. Like, you are annotating a particular text to different categories. Like, you want to know a particular text given unto you. Maybe this text, what are the categories you have there? Do you have some organizations mentioned there? Do you have some people mentioned there? You don't have the time to read the whole text, but you can perform named entity recognition to have an idea of the different entities in that text data. Here, I put a label of Google Cloud API on sentiment analysis and named entity recognition. For instance, you have a particular, just 2 lines of text here. This is Google Cloud API. And you have Google headquartered in Mountain View, unveiled the new Android phone at the Consumer Electronics Show. and you have this. And then when you click this analyze on their platform, it will give you the entities and the sentiments associated with that sentence. For instance, it shows here, it was able to, that API was able to recognize Google as an organization. Users here, in the second sentence, it was able to recognize that as person. And for each one, is giving you the sentiment. The sentiment is based on the words. It's trying to detect if they are negative emotions, negative words, or positive or neutral. That's what this score is giving you. You see, it was able to recognize phone as consumer good. So you don't have the time to go through all the text, but you can build an API like this to help us understand the different, the entities in a particular text. Another one, common one, is machine translation, which is translating text in one language to another target language. For instance, we have here the Google Translate, which helps to translate Chinese to English. Look at a particular, this Chinese sentences, and look at, it was able to translate that to these English words. So the reason this is good is because, for instance, people who want to travel, let's say a Chinese man want to travel to an English country, let's say US, using this kind of app will help the person to understand English, like it types in the Chinese language, Chinese words, and is able to understand what that is in English in case it doesn't even understand English. So a common one, which we're going to quickly look at, another one is text to speech or speech to text. And I'm going to copy this one in case you want to run it with me. You have to install some things to be able to play this. And you can play around it in your own leisure. So I'm going to copy this, but because for you to run this code so that it will translate the sentence to words, to speech for you, you have to install this in your stuff. So make sure I'm going to copy it with a comment. Let me just comment it, and then I'll copy it and put it in the chat for you. So the main thing, let me just copy this, copy the chat. So you can, so I've sent that to you in a chat. You can copy that and install it in your notebook. Then you'll be able to run this. What I'm trying to do here is I want to feed in a particular sentence into this and let Python help us convert those words to speech. So I'm going to run this. I won't comment this 2 lines because I have already installed it here. So there's no need installing it again. So look at this. So I have run that already. So the next thing I want to do is to save the audio file, which is, I already saved it. I import GTTS, is a particular library that will help us convert our text to speech. And same thing with the play sound. So what I did here is to call the GGTS. There is a function in this GGTS called also GGTS, but the double T are capitalized. And then I can pass in my text. The next thing, after you run that cell, the next thing is to save that text as an MP3 file. And then we can now play it using the play sound library. Watch. Natural language processing is an exciting field in data science and artificial intelligence. That is it. So this is the advantage of NLP. You can convert text to speech. Vice versa, you can convert speech to text. Some of you are aware of Cortana in Microsoft, so that's what it's doing. When you pass, the Cortana can help you convert your text to speech and even speech to text, things like that. These were built using natural language processing. So the field of natural language processing is very exciting and very wide. So is actually a field that is growing and has application in almost every business. So, but that is that about that. But because natural language processing involves dealing with text, we're going to start using strings. Start, working with strings. I know most of you are aware, you're familiar with this. So I'm going to be fast with this because what we want to do today is to talk about strings, talk about what we call tokenization, stemming and lemmatization, removing stop words from a particular text, and also displaying the frequency distribution to look at how frequent a particular word occurs in a text. That's what we're going to do today. And we'll break you into breakout room for you to quickly practice that. So I'm going to start with strings because you're dealing with text. Remember, just to refresh your mind, that a string is a sequence of one or more characters. And a string is immutable, meaning once you define a particular string, you cannot change it. You cannot adjust it. For instance, if I define a variable, a string S as this sentence, Shagun is here. Suppose I want to modify it. I want to modify the second sentence in this string as I want to replace it with A. You will see I'm going to get error. Why? String object does not support item assignment because a string is immutable. You cannot change it once you have defined it. Okay, so yeah, so that is one. To get the length of the string, use the function len to get the length. Remember, len is a short form of length, and then you pass in your string that you've already defined. Now you have this 13. So what it's going to do is going to count it starting from 0, 0, 1, 2, 3, 4, 5 with a space, 6, 7, 8, 9, 10, 11, 12, 13. It's going to count space too together with it. So when you apply the function length on a string, remember it's going to count the space between the string too. So to move on, we want to look at string indexing. That is, how do you index a particular string that you have already defined? Suppose you want to get the first 5 words, the first 5 characters, letters that you are in the string you've already defined. Then you can use a square bracket anytime you are indexing. The colon here means if I use a colon and do not put a particular number before, like for instance, if I put 2 here, that means index this string starting from the 3rd character. Remember, Python is 0 index, meaning 0, 1, 2, starting from G and then go to 5. However, it's not going to include the last number. That means it's going to go from 2, 3, 4. So let's see what that will give us. You see, it's starting from G, which is 2. S is 0, E is 1, G is 2, 3, 4. It's not going to include the 5th one because when you index, it's not going to include the character, the number you include there as the last one. So, but suppose I just put empty colon. That means it's going to start from the very beginning to 5. But remember, it's not going to include 5. It's going to stop at 4, but it's starting from 0. So, see, he gave us Shagun, meaning 0, 1, 2, 3, 4. That is about indexing. You can play around that to understand more. Suppose you want to get the last sentence, the last character, I mean, just use -1. Okay, and that gives us the last letter there. That's the last word. You want to reverse it, use double colon, and then put -1, meaning this first column means start from the beginning. This last column means go to the end. But -1 means start from the end. So that's what it's doing. So you see, it starts from the end, E, R, E, H, something like that. You can see. So that is that about that. All right. So let's quickly look at the different methods, and then we go to for loop. These are the different stuff you're going to use. That's why I'm going through them. You are going to use them as you work with text. So let's look at the different methods that you can apply on string. This is also to refresh your memory. I know we covered this in the first training that we did. So suppose we define another string called variable str2 as what we think will become. And we are interested in counting the number of e's that we have there. Just apply, call the string str2, and then apply the count method on it to count. What do you want to count? E. So if you run that, it's going to give us the how many e's, the number of e's that you have in that sentence. If you look at that, we have 4. Let's count that. We have 1, 2, 3, 4. So that is how to count a particular letter or character in a string. Now, suppose you want to know the index where the word think actually starts in a particular text. You can use the method find. So just call your string and then use find. Find what? Think. What is going to give you? It's going to give you the index, the position where think starts in that string. And then you can see it's 8. To confirm that, 0, 1, 2, 3, with a space, 4, 5, 6, 7, and then 8. So it's telling you that the word think starts at position 8. So you can also change your string to uppercase, like capital letters. You can convert them to uppercase. Similarly, you can convert everything to lowercase. We're going to use this, so take note of all of these. You can also capitalize it, meaning it's going to turn the first character, first letter of that sentence to an uppercase. You can see it turns only W was turned to uppercase. If you want to turn the first letter of each word in that string to an uppercase, then you have to use the tie to method. You don't need to memorize it. Remember what I told you. Once you put string dots, just press tab. You scroll down, it's going to give you all of that. So you see, the first letter of each word there was turned to an uppercase. And finally, which is an introduction of what we call tokenization, one way to get that is apply the method split on your string. Split. If you do that, you can see what this does is that it splits your string by the white space. White space means the space. So once you look at what, it's going to separate that from the next one using the space like that. So, and you can see you have what we think, including the comma that you put here. If I put a dot here, it's going to include that. You can see I have it here. So that's so each of these, I'm going to buttress more on this later. Each of these words is what we call tokens. So tokens are individual words, but let me pause here until we get to that place. The last one before we start tokenization is the control statement, where we have the if, else, and the for loop. And so what are control statements? These are just words. Control statements are just statements that a particular program follows to get a desired result. You know, so and what we look at here, we'll briefly look at the if else, the else if, and then the for loop. That's what we're going to look at. So suppose all I'm doing, since I look at the people who are here, all I'm doing is just to refresh your mind. Most of these things you're already aware of that, but these are the foundations of the NLP techniques we're going to discuss. Okay, so suppose we want to get input from an outside user. That's why I'm using the keyword input. I want the user to enter a password, and if the password is equals to MI6, note the double equals, meaning an equal sentence, an equality sign, just this, is not an equality sign in Python, is an assignment symbol. Equality sign in Python is double equal sign. So once the user enter a password, you want to check if the password is equal to MI6. If that is correct, you want to say, oh, welcome, Mr. Bond. So suppose I run that cell, it's going to ask me to enter a password. If I enter MI6, then it's going to tell me, welcome, Mr. Bond. But suppose I enter a wrong password, if you stop at just if, it's not going to do anything. Suppose I put Kenny. See, it didn't run actually. It didn't give you the desired result, but it did not tell you that your program is wrong. It just move on. It just terminates. That's what this does. So suppose we want to catch it. So that's where S comes in. That, oh, if this particular program is wrong, then do this. So it's not going to come to S until the statement under the if block is until that the statement under the if block does not run, is incorrect. That's when it's going to come to S. So let's do this now. Okay, if password is equal to MI6, print welcome Mr. Bond. But if that password is not equal to that, what do you want to print? Access denied. So we have this. If I put Kenny this time around now, it's going to tell me access denied because the password that we put there is MI6. So that is where if S comes in, right? And you can extend that if you want to have series of control statements, series of steps, you can extend that to S if. In programming language such as C++ or Java, you use if, then S if. But in Python, the S if is shortened to L if. L if. So, but if you're dealing with C++, you have to spell out the S if in full. So the first thing I want to do, I want to write a program that will give us the grade for the score of each student, of a particular student. That we want to get a score from a user, we convert it to float, meaning we want it to convert it to include decimal numbers, okay? If the essence of putting that as a float is because if you do not put that float, if a user enters a number and it includes a decimal point, it's going to tell you error because you didn't convert that input the user is giving you to a float to include decimals. So that's why we put float there. Input is always used to get something from a user, okay? So and we save that as a variable score. So if the score that the user gives you is greater than or equals to 4, print your grade is A. S, if the score is greater than 3 and the score is less than 3.5, print your grade is B. You can include another F, many S if, depending on your series of steps. S if score is greater than 2.5 and score is less than 3, print your grade is C. So if you are done with all of these steps, S, print your grade is D, meaning if the score is less than 2.5, then it's going to give us grade is D. So if you run this, if I put 4.5, it's enter your score. If I put 4.5, it's going to give me A because the first condition is satisfied. If I put, let's say, 2.49, it's going to give me D because all of the other steps are not satisfied. So it's just going to give me the last, default value. Your grade is D. So that is all about effects. One thing you should understand is anytime you use the if statement, it must end with a colon. The same thing with the S if. You must end that sentence with a colon. Take note of that. So we are moving to for loop before we start tokenization. For loop is used to iterate, meaning to iterate through a particular sentence or a particular text or a particular list. And we're using range here. Let me demonstrate range. Range, for instance, if I put range of 5 here, what I know Python is going to give us is values from 0 to 4. It's not going to include the number you put there. But if you just use ordinary range, range is an iterator. It's not going to give you, it's just going to return, oh, the range is from 0 to 5. But if you want to see the values there, just wrap everything around lists, okay? Wrap it around list and it's going to tell you, oh, range 5 is from 0 to 4. So that's what I'm doing here. That, oh, for A is just a counter. It's just a variable to count. For A in range 5, meaning A going from 0, 1, 2, 3, 4, as far as you are in that block, print hello whole. Suppose I just want it 3 times, I can put 3. For A going from 0, 1, 2, print hello whole. So the first time A is going to be 0, it's going to print hello whole. When A is going to move to 1, it's going to give you hello whole. A is going to give you to 2, going to move to 2, then it's going to give you hello whole. Things like that, you can see. So that is for loop in general. So for loop is just to iterate through a particular list or string. So suppose I want to print each character in this NLP basis. All I do, so you can see, this one is just a counter. It doesn't matter. You can use A, you can use anything, IT, anything. It's just a counter. For I in this, what this I is going to do is going to go through each character in this string, starting from N, going to L, going to P, the space, and each of them. So the first time I is going to go iterate, is going to pick N, then print it, N. The next one is going to go to L and print it, something like that. So that is a for loop. So the main thing we're going to discuss today is just tokenization. But before we start tokenization, I want to give maybe 30 few seconds for questions. Any question here? Any question? You can unmute if you have a question and ask. Any question? So are we good?
Sorry, I have a question, Mr. Kenny.
Okay. Mm-hmm.
Yeah, when you ran the code for the sound that we heard.
Which one?
From the when you were giving an example of NLP.
Okay.
I think you ran a code and we heard the voice.
Yeah, I was trying to show you how to translate text to speech.
Okay.
So I just
my question. Yeah, my
okay.
question now is which of the code, because I'm not seeing any outputs. Is the output the voice that we heard?
Yes, the output is the voice that you hear.
Okay.
So you can play around it. That's why I copied the code for you and put it in the chat for you to install those package with the GTTS, Pi, all these play sound and all of that. So when you install that, if you follow you can put any text you want there, save it in a variable, and then save that text.
Okay.
You are saving it. That's what the second cell is doing. Save it as using any name but .mp3. You want to save as MP3 format.
Okay.
And then to play it. When you save it, it's going to save in your directory. See, can you see the directory?
Okay, it's there. Okay.
Yeah. Okay. So if you now want to play it, just call on the play sound. That's why I put from play sound, import play sound. Play sound, then put in that your MP3 audio that you save. If you put anything, it's going to read that for you. So that's what I was.
Okay. Thank you so much. I understand now.
All right. Okay. So we're going to start main NLP work now, starting from what we call tokenization. Tokenization is the process of segmenting text, a particular text you have, into individual words. Those words are what we call tokens. Each of those words are what we call token. Why is this necessary? If you have a particular text, be it a book or a paragraph or a book, a literature book, a novel, for you to work with that, for you to analyze those texts, for you to manipulate it, the only way you can do that, you have to convert all those sentences to words, to individual words, like segment them, separate them to individual words called tokens. But tokens does not only include words, it also includes the punctuations in those texts. So, because if you can only work with words, mainly individual words in natural language. That's why tokenization is the first step, is the first thing you do before you, like in manipulating or analyzing the particular text you have. So for you to do that, I'm going to copy this for you. You have to install, we want to use a popular natural language processing toolkit in Python. There are different ones, but we're going to work with just NLTK. That's the natural language toolkit. We have Spacey, we have Gensim, but each of these can be used to manipulate text. Maybe in our future training, we'll organize a training on Gensim to analyze text or Spacey. But today we just want to use NLTK because it's very simple to learn. It's very simple to work with. So I'm going to copy you have to install the toolkit. I'll copy this tool code for you. Make sure you, okay, just let me uncomment that for you. Or just make sure you uncomment that, remove the pound symbol. So I'll copy this, pip install that. When you call nltk.download, it's going to open a new window for you. Maybe I will even show you. So better, let me show you. So let me put that in the chat for you so that you can install that. So just run that, comment it, remove this hash symbol, and then run the two on your Jupyter notebook. Okay, so if I run that, I already have NLTK installed, but suppose I want to run the second line just to show you what you will have in your notebook. It's going to open a separate window. Oh, sorry, let me import it first. I have to import it. You don't need to import it because you want to download it. So when I import, it's going to open a separate window for me to download some things. So it's running. Once it runs that, although I already have those downloaded, but I just want to show you what you will have. Okay, so it has already opened. So you see this symbol. If you click it, look at what it's going to give you. For you, you are not going to have this installed. Just click download, and it's going to install all of this. So before we are done, you should have all of this installed for you, depending on your internet anyway. So just run that. It's going to open this window. Click on that and click download so that it will download all of these. Because the data we're going to use from the NLTK is included there. So I will just cancel that because I already have that installed. Okay, so run that and you will have that. So suppose you're able to do that. The first thing we want to do, we want to tokenize. We want to segment a particular text or a sentence that you put there into individual words called tokens. So there is a function in NLTK called the word tokenize that will help us do that. So you don't have to memorize that like I normally tell you. From NLTK, once you put import and then press tab, it's going to load and then you can scroll down. Let me just put W to help me. You say word tokenize. So that's the function that will help me to tokenize. Tokenize means to divide, to segment. So suppose I want to tokenize this sentence. By 11 o'clock on Sunday, we'll visit the cinema to watch a movie. So I will just pass that sentence, that's a string, to word tokenize. Remember, word tokenize is the function. I want to save the output as tokens. Tokens is just a variable. You can use any other variable. And then if you call that again, it's going to give me, see, you already segment each of these to individual words using the space by 11, then o'clock. It recognizes that o'clock is a compound word. On Sunday like that, it includes the comma, it includes the full stop there, you can see separately, the punctuation. So tokens are individual words in a text, including the punctuations. So the first thing when you have a text is to first split the text or tokenize the text into tokens. So we call token the basic unit of text. So that's how to tokenize a particular sentence to words. There are several tokenizers. We have the tweet tokenizer to help us tokenize tweets. We have even sent tokenize is used, and that's the next one I'm going to look at. That suppose you have many sentences, and I want to first split this paragraph or this large corpus. What is a corpus? Sorry, I'm just introducing. A corpus is just text. These are terminologies that I use. Corpus just refers to text. So I know when you hear corpus, you are just talking about text, a given text. So suppose you have a large corpus or multiple sentences, and you want to first split it, you want to first tokenize it to individual sentences. Individual sentence. I mean, you want to first split it or tokenize it into to list of sentences before you now tokenize it to individual words. You can use the sent tokenize. So from NLTK, since I already imported NLTK, so let me just import the library from NLTK tokenize. You can even put tab there. From NLTK tokenize, import. Remember, you don't have to memorize. So import. See, there are many tokenizers. Blank line tokenizer, line tokenizer. But the two common ones, in fact, there are three. The word tokenize, the sentence tokenize, and the regex. That's the regular expression, but you won't need that here. So the sent tokenize. We use the sent means sentences. We want to tokenize a particular text to list of sentences. So we import that. So this is the text we want to tokenize. Okay? So the first thing you need to do is to pass that text into your sent tokenize. So let me run this. And then so pass the text to your function sent tokenize. We want to save the output into a variable called sentences. Remember, you can use another variable, and then you can run that, and it's going to give you this. Now look at the output. It tokenizes it, separating it into list of sentences using the full stop. Look at the first sentence, natural language processing, and it stops at data. That's this data, this full stop. It picks the next one again, this second line. This second sentence, it is popularly abbreviated as NLP. You can see it stops there. It picks the next one, NLP involved deriving, and look at where you have a full stop, which is decisions. You can see it picks that the third sentence. Then it picks the next one again, applications. Applications of NLP can be found. It stops at engines, search engines. Look at it here. You can say until is looking at, so this sentence tokenize, this sentence tokenize is only going to tokenize your paragraph, your text, into list of sentences. The sentence is where you stop, where you put full stop. So once you do that, you can now tokenize each of these sentences into words using the word tokenizer, or the word tokenize. However, if you want to do that, you have to use for loop. Since you already have list of sentences, we want to iterate, we want to loop through each sentence and then print out the word in each sentence. And that is what this for loop is doing. That since I already saved it in a variable called sentences, I'm using this counter called sense. You can use any other one. You can use A, you can use I. But I just want to use something meaningful so that next time you read it, you understand what you're doing. That for sent in these sentences, what this is going to do, sent is picking each sentence, not each word, each sentence. For sent in sentences, remember what you have in sentence is a list of sentences. So what this sent is going to do is going to loop through each sentence. So the first sent will be natural language processing and stops at data. What do you want to do? I want to tokenize each word in that sentence and save it into a variable called words. And then I want to print it out. So it's going to do that for each sentence, putting them in a list, in a square bracket. So you can see, if I run this, I'm going to have this output. So the first sentence, it takes the first sentence and then split this sentence by white space, meaning the space, and give what natural language processing is like that, include the full stop. And it does that for each of the sentences. But we can also put all of this code in just a single line. And that is the idea of list comprehension. I briefly talked on this on the last training. So I'm just going to refresh your memory on that. So suppose we want to save this as token list, okay? So open a list, a square bracket, and then let's put all of these 3 lines code in a single line. There are 4 cents in sentences. What do I want to do? I want to tokenize it. So just put space there. I want to word tokenize of what? Of my cent. And then the result, I save it in token list. So let's call it back to see the output. And you see, so you can see the first list, it gives you back natural language processing, blah, blah, this data. So you can see you put each sentence in a list. So this is what we call list of lists, because you have different sentences. Each sentence is in a list. So this is what we call, this single line is what we call list comprehension. So you can put your for loop in a single line. Most times it's very good. It makes your code simple and short. Yeah. So that is that about tokenization. Before I move to stemming and lemmatization, I want to quickly allow 1 or 2 questions. Any question on tokenization? Anybody? Okay, so are we good on that?
Yes, we are good. Yes.
Awesome. So let's move to the next thing you will do. We call it stemming or lemmatization. Stemming is the process of reducing a given text or a given word in a text or a word in a text into its base form. You know, there are some words like go, goes, going, gone. So when you apply stemming on it, it's going to reduce it to its base form. The essence of this is because you don't want to just have words in your text that are saying the same thing, that means the same thing. We want to reduce this so that we can, so that our corpus, so that we're going to focus on the important words in that text. So stemming is the process of reducing, chopping off, like removing suffixes, removing endings, words, the endings in a particular word to reduce them to the base form. So that base form is what we call the stem. Yeah. And what we use to chop off or to remove those suffixes are what we call the stemmers. Okay? So there are different stemmers in NLTK, in natural language 2K. But the popular one is the Potter stemmer. We have the snowball stemmer, Lancaster stemmer, and so on like that. But the most widely used one is the Potter stemmer. Okay, so, and it's in the stem method. So if you put from NLTK the stem, if you put, let's see it, NLTK the stem, import, if you press tab, it's going to show you different ways. You can see Lancaster stemmer, Potter stemmer, which is the one we need, reggae stemmer, snowball stemmer, and the WordNet lemmatizer, which is when we get to lemmatization. But the one we need here is the Potter stemmer, okay? So when you import that, the next thing, instantiate it, Potter stemmer. Remember to put this bracket. So what we now want to do, suppose we have a word list called enjoy, and the variation of that word enjoy. Enjoys, enjoyed, enjoying, enjoyable. We want to get the stem, the base form of that. So what do we need to do? Remember, it's a list, so we have to loop through it. Now, okay, for talking in word list, meaning go through each of the words and stem it. To stem it, remember we already instantiated it and saved in a variable called PS. So when you call that PS, you have to call the word stem and then pass in the token, meaning each of these words. Remember, if you do not call this stem on the object, this Potter stemmer, is not going to run, it's going to give you error. So this stem means I want to stem that token. I want to reduce it to its base form. So when you do that, and then you call it back, it gives you, you can see it stem all of this word to enjoy, because it recognizes that the main word here is enjoy, and they're all saying the same thing. Sometimes it may not, it may be incorrect because maybe you need the particular meaning enjoyable. So, but stemming will give you the base form. Stemming will assume that you are all saying the same thing. You are all talking about that you enjoy something, whether you are saying enjoying, enjoyable. So if that's what you mean, that the main thing you need is that word enjoy, then you can use stemming. But if you actually need that word, the different variations, you might not, then you may consider not using stemming, because stemming will just give you the base form of that. You can, another example, I put a word go, gone, going, and goes. Then I want to look through it. Remember, here I did not use list comprehension, but you can as well use list comprehension. Therefore, this counter called talk in these words in this list. What do? Stem it. Now, if you do that, you can see it helps us go, gone, going. It stems the going to go, but goes, it only remove the S, and GOE makes no sense. So sometimes stemming to fails. It doesn't give you the output. So that's why you as a data scientist or someone who is in the field of natural language processing, this is case by case stuff. It depends on what you need, what you want. So that will determine which of this method you are going to use. None of them is perfect, but they do good. They do actually a fine job. But you also need to understand what you need at a particular time. So suppose you have string of text. So let's combine the tokenization and the stemming together, because in most cases in real world, it's not as if you are just going to do tokenization and stop there, or you're just going to do stemming and stop there. These are series of steps which you will put together, and you will see that in the breakout section. So suppose you want to combine the first two things we've talked about, tokenization and stemming, meaning tokenization, remember, segmenting the sentence into individual words called tokens, and then stemming, meaning removing, chopping off the suffixes or reducing a particular word to its base form. So suppose we have a raw text like this, my name is Maximum, blah, 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 and all of that. So the first thing you want to do, remember, is tokenization. And you can use the word tokenize from NLTK. So the first thing, I pass the raw, this sentences, this text to word tokenize, to tokenize it, and I save the variable as tokens. The next thing, I want to stem it, meaning I want to remove, I want to reduce it to its base form. So what do I need to do? I will loop through these tokens and then stem it. So if you do this, let me run this cell. That's because I didn't run this raw first. Okay. So look at it. My name is, but look at stemming. Not stemming, if it's confused, if it doesn't understand that word, it misbehaves. It doesn't know the word Maximus. Look at what it gives. It removes the X, maximum. And to us, that makes no sense. The same thing with decimal. He removes it. S, he removes all of the S. See, commander, it will help us to pick what the base form of commander is command. So stemming just give you the word command. So army, where we have army, where is the armies? He give us army, ARMI. So sometimes it may not be giving you the result you want. So that's why you need to see vengeance. It removes the E. This vengeance here. I will have my vengeance. Vengeance, it removes the E from there and give us, where is it? Yeah, vengeance. So sometimes the result of stemming may not be perfect, may not be what you need. So that's why I said this is case by case scenario, depending on what you want. So most times, make sure you go through the result, what stemming is giving you, to be sure that is what you need. If not, there is another alternative called lemmatization. Lemmatization is also trying to remove inflectional endings, the suffixes of a word. However, lemmatization match the word to a dictionary. It has an inside dictionary. So what lemmatization does, or a lemmatizer does, is to look at each token and check it in the dictionary and look for the dictionary base or base word of that token that you gave it, that you supplied, and give you the dictionary base form. If it's unable to find a suitable dictionary base form, it's going to give you back the word instead of removing it, instead of giving you, it's just going to give you back the word. If it's able to find a dictionary one, then it's going to give you the dictionary base form. However, because lemmatization involves checking a dictionary to give you the base form of that token, is most times slower compared to stemming because it's checking a dictionary that is inside. So how do we implement that in Python or in NLTK, Natural Language Toolkit? Still in that stem, NLTK stem, there is a lemmatizer called WordNet lemmatizer. Okay, that's the most popular or widely used lemmatizer. So the next thing, just like stemming, we instantiate it and we save it in a variable. You can use another variable by use WM. Okay, and then just the same way, the same approach you did stemming, look through it. That okay, I want to look through that same word list, this word list, this enjoys, and all of that. I want to look through it. Okay, so for word in that word list, you have to implement lemmatizer, WordNet lemmatizer. Instead of this stem, you are using lemmatize here. You call the object that you instantiated, and then you call lemmatize. What? You want to lemmatize each word. So if you pass that to it, see, it gives us, you can see it's running. It's kind of slower compared to stem. It gives us back those words because lemmatization, is going to be checking the word with the dictionary base form, and it takes context into consideration. So enjoy, give us back enjoy. Enjoys, instead of stemming it back to enjoy, it gives enjoys back. The same thing with enjoyable. So you can see, this depends on what you are working on. If you actually need those words back, like the context, then you should use lemmatization. But if your goal is to get the main base form, enjoy, like in this context, then you have to use stemming. The same thing, if we do that for the go, gone, going, and goes, see, if you run that here, it gives us go. It only stems go and goes to go, unlike the stemming that removes the S. You can see. So having knowledge of these two will help you so that if what you need, stemming cannot do it, then lemmatization should be able to do it. So you play around the two to know which one you want. Okay? So we can compare stemming and lemmatization to see the work. So the first thing I did, I import the word tokenize. If you have done that before, you don't need to keep importing it. This is because suppose you are working with it different times. So import the word tokenizer, and from NLTK stem, import the porter stemmer and the WordNet lemmatizer. Suppose this is the raw text. So the next thing, I instantiate both porter stemmer, WordNet lemmatizer. Then the next thing, I want to get the tokens. Remember, the first thing is tokenization. I want to tokenize the sentence. So I use word tokenize and pass in the raw and save it in tokens. So this next line is getting me the stem, the result of stemming. For word in these tokens, convert that word to lowercase. I want to make sure they are in lowercase. Remember, I used the lower method for you in the Python string. So convert that to lowercase and then stem the result. That's what this line is doing. The same thing for lemmatization. For word in tokens, convert that word to lowercase and then lemmatize it. Okay? And then if I want to see the output, so this is the output for stemming. It gives you this. We've already seen the result. I just want to put everything together. And if I want to see, you can say maximum, you remove those X and all of that. Vengeance. But suppose, let's see what lemmatization will give us, if it's going to be better. See, He gives us, because he couldn't find the base form of Maximus, he gives it back to us, Maximus. When he says commander, he gives us back commander. Murdered, instead of, but in stemming, murder, he changed the murdered to murder. He gave us the base form, murder, in both cases. Murder and which other one? Murder, yeah. But in lemmatization, he gave us back murdered. So sometimes stemming is preferable and sometimes lemmatization is preferable. But in general, people, data scientists usually prefer lemmatization because stemming might be too harsh in most cases. Okay, so the last one, okay, the next to the last one is the stop word remover. Okay, removing stop words. What are stop words? Stop words are frequently occurring words, but these frequently occurring words, they do not really convey a special meaning or the actual meaning. They are not that relevant to the task at hand. So that's what stop words are. If you look at this one, look at is, of, the article D, and I, to, they occur so much. And that might not really convey the meaning, the actual word, the actual meaning of the sentence. So in natural language processing techniques, is mostly preferable to remove stop words. So, but there are built-in stop words, and you can also build in yourself, build your own. But we want to use the built-in stop word. We can check them. So the stop words, we have stop words in this NLTK corpus. So if you have installed what I told you to do, you will have this there. So from NLTK corpus, corpus refers to text, import stop words. So when you import that, you have to instantiate it. But there are stop words in several languages. So we have to tell Python we need the English stop words. So when you call this stop word that you install, call on words and pass in English there. That will download the English stop words for you. Let's see the stop words that is downloaded for us. See, these are the different stop words in natural language toolkit, NLTK. I, me, my, myself, we, ours, like that. Them, and so many. There are a lot. You can also add to this list. Mustn't, mightn't, all of these, shouldn't. You can add to the list. You can extend it. But for now, let's just make use of the built-in one. So we can import that. We can download that. Okay, and save that in a variable called stop_words. We can also remove punctuations, all those dots, all those commas. You don't really need it in your text analysis. So to do that, import string. And when you import string, there is an attribute called punctuation. So what we want to do, I want to put the two steps of removing stop words and punctuations together, and then we'll combine all the four steps together, and I'll give you some work to do. So suppose this is the text. I love NLP because it is relevant to almost every aspect in data science career. That's the text. That's the text you want to you want to manipulate. So the first thing, tokenize it using word tokenize. Pass the text to word tokenize. So that will give us tokens. Then I want to look through each token and convert it to lowercase, and then remove the stop words and also remove the punctuation. So what I will do for talk in tokens, look at the if now. If the lowercase of this token is not in this list of my stop words, that's why I use not in. It's not in these stop words, which are already saved as stop_words. It's not in that. And that same token is not in punctuation. You have to call the punctuation on the string that you import. If the token is not a stop word and is not a punctuation, print it. And if you run that, you're going to have this. You can see he removed I, give us love, NLP, he removed because, it is, he removed those ones. He give us relevant, two, he removed that. You can see, he give us the keywords there, love, NLP, relevant, almost every aspect, data, science, career. It gives us the relevant words and remove those. All of the other ones are called stop words. You can also use list comprehension, put all of these in a single, maybe in 2 steps. Just first tokenize it and then remove the stop words and punctuation. So let's put all together, do frequency distribution, and then we quickly do a short exercise. So first, import the string, then tokenize the raw text. Put the text to what tokenize. The next thing, I want to convert to lowercase. Why are we converting to lowercase? Because Python will recognize the same word, but in different case differently. If you put love starts with normal L, small letter L, and another love starts with capital letter L, Python is going to see them as 2 different words. So that's why we normally convert them to lowercase, so that once it sees a particular word different time, it's going to recognize that it's the same word. So it's a good habit. So convert it to lowercase, lower. And so for word in this token, convert it to lowercase. That's what this first line is doing. The second line, we want to now look through the result of this next token. So we said that for word in tokens, print the word for me if not word, if the word is not in stop words. I could use not word or I could use word not in, any one of it. So if that word is not in my stop word, and also if that word is not a punctuation. So if you do that and call the token stop, token, and call the result, name token, tokens, sorry. So it's going to give us, you see, these all words, see, it just gives us, it removes, so all we now have here, we do not have any stop word there. We do not have any punctuation there. So that's what we have here. So you can remove that. That will help you to remove a given corpus to manipulate whatever text you have or a particular corpus you have. Before we do the last step, which is frequency distribution, do you have any question on stemming, lemmatization, and stop word removal? Any question on that? Are we good?
Yes, sir.
Okay. So the last step is just to show, to visualize the filter, the clean text you already have. Today, I'm only going to show frequency distribution, but tomorrow I will give you another way to visualize your text, which we call the word cloud. That one is used mostly in marketing firm, to quickly visualize your word. But today, let me just use word frequency distribution. So you can import that from the NLTK too. From NLTK, import freq disk. Since we want to visualize, we need the matplotlib library too. We've already walked through that in our last training. So import that as PLT. The first line here is optional, but it's creating a figure. You want to create a figure, PLT the figure. Set the figure size, the size of your figure. I want to use the width of 8 and the length of 5. It's optional actually. So the main line that display that is this second line, freq disk that you import from NLTK. Passing this token stop, passing your clean text into it and save it as freq. Then to plot it, call on the plot function or the plot method on that frequency. What this line, second line, will do is to give you frequencies of the words. It's going to give you the number of times each word occur in a particular text. So this third line is displaying that word with its frequency. Cumulative equals to false means I don't want the cumulative, meaning the addition of all of that. I just want the plot of showing the frequencies of each one. And then if you run that, it's going to, give you the word that occurs there. And you can see here, murdered occurs twice. Every other word occurs once. So that's why it's giving us all of the other ones are one, but the word murdered occurs twice. Okay? So to introduce you to the exercise, we're going to use the corpus in NLTK called Gutenberg. So that's the word, that's the corpus you're going to use for your exercise. But in that Gutenberg, there are several text files. I want you to use the Bible KJV text. In your leisure time, you can play around other texts. So the first thing I did is to import that Gutenberg from NLTK corpus. You don't need to import store words if you have already done that above, but here, just import the Gutenberg. To check the different files you have there, that's what I'm using, the file IDs. So if you run this will just give you the different files you have there, these file IDs on the Gutenberg. But I want to use the Shakespeare Hamlet just to, as an example of how you will load your own Bible KJV.text. So call on the Gutenberg. I need the words in that text, the words, the tokens there. So call the words and pass in the text. And then I save it in a variable called shakes. I ask for the length. So I have about 37,260 tokens there. And then you can start manipulating it. So, that's what I just did here. That, for talk in shakes, convert the tokens to lowercase. I only need words whose length is greater than 3, but that's because that's what I want. So that is that about that. So that's the exercise you are going to work with, but I want you to use the Bible KJV text. So before I stop sharing and break, and so that you can walk through this exercise, any question? Any question? Are we good? So can we
Yes,
start?
sir.
All right, so I'm going to stop sharing and I will stop recording so that you can do the exercise here. So, all right.